Now let us discuss one numerical from the calorimetry chapter. Now here is one question. Calculate the amount of ice which is sufficient to cool 150 grams of water contained in a vessel of mass 50 grams whose specific heat capacity is 0.4 joules per gram per degree Celsius at 30 degrees Celsius, such that the final temperature of the mixture is 5 degrees Celsius. So basically the question is something like this. You have a vessel whose mass is 50 grams and whose specific heat capacity is 0.4 gram per joules per gram per degree Celsius. Now inside this you have water which is 150 grams and you are pouring some ice. Obviously if the temperature of the ice is not specified, you should take it as 0 degrees Celsius. You are pouring some ice and initial temperature of this system, the vessel plus water, the initial temperature is 30 degrees Celsius, and when you pour the ice, the final temperature of once the ice is inside, the final temperature becomes 5 degrees Celsius. So whenever you attempt such question, please go through the question properly and find out what is actually happening there. So here you have a vessel whose weight is 50 grams, inside it water is there of 150 grams, both are at 30 degrees Celsius. The specific heat capacity of vessel is given and specific heat capacity of water should be known, that is 4.2 joules per gram per degree Celsius. This is for water. Now ice is being poured. If the temperature of the ice is not specified, you have to take it as 0 degrees Celsius, and final temperature of the whole ice being poured gets converted into water. That water plus already present water plus the vessel finally reaches a temperature of 5 degrees Celsius. Now how to solve such questions? See, whenever you go through the calorimetry chapter, you will come across two equations. First equation is Q is equal to mc delta T, and second one is Q is equal to m into L. If you understand both equations, then you can attempt any sort of questions. Now let us see what, before getting into the question, let us see what this Q is equal to mc delta T and Q is equal to ml is. First of all, Q denotes, so let me write Q is equal to mc delta T. See, Q denotes the heat absorbed or evolved by a body. M denotes the mass of the body, and C is specific heat capacity of the body, and delta T is the change in temperature which is happening. For example, if in this particular question you can see 150 gram of water, so mass of water is 150 grams, and specific heat capacity is a constant for a material, and for water it is 4.2 joules per gram per degree Celsius. I will explain what specific capacity is. Then delta T is the change in temperature which is happening. For example, here the water initially was at 30 degrees Celsius and finally it reaches a temperature of 5 degrees Celsius. So how much temperature difference has happened? From 30 it becomes 5. So what is the difference? 25 is the delta T. Now let me explain what this specific heat capacity C is. Specific heat capacity is defined as the amount of heat required to raise the temperature of water. In this particular case, let me take the example of water. To raise the temperature of water from 14.5 degrees Celsius to 15.5 degrees Celsius. See, Q is amount of heat required to raise the temperature of, unless I specify how much amount of water, if I write it like this, it becomes heat capacity. So without specifying what is the mass of the body, I simply note down the amount of heat absorbed by the body to raise its temperature by 1 degree Celsius. It becomes heat capacity, denoted by capital C. When I specify how much amount of heat is required to raise the temperature of 1 gram of or 1 kilogram unit mass of that substance, then it becomes specific heat capacity, denoted by small c. That is the only difference. So heat capacity is the amount of heat required to raise the given mass of substance through 1 degree Celsius. Specific heat capacity is the amount of heat required to raise 1 gram or 1 kilo or unit mass of the substance through 1 degree Celsius. So that is about specific heat capacity and heat capacity. So for water, it is 4.2 joules. So water, 1 gram of water requires 4.2 joules of heat to raise its temperature by 1 degree Celsius, means 14 to 15 or 50. So standard value is given from 14.5 to 15.5, and or to a certain extent the expansion of water or the raising temperature of water is linear. So we can say it is from 50 to 51 or 51 to 52. So any 1 degree rise, 1 gram of water, for any 1 degree of rise, it requires 4.2 joules of heat. So hope you understood what this specific heat capacity is. Now, I said about the second equation, Q is equal to m into L. Here also Q specifies the heat absorbed or evolved. M is the mass of the body. Now what is this L? This L is latent heat of It can be latent heat of fusion or it can be latent heat of vaporization. Let me explain what latent heat is. See, during melting, that is, if you have an ice block at 0 degree Celsius, initially it will get converted into 0 degree Celsius of water. Then only that water's temperature will rise. For example, if you are providing heat to a block of ice which is at 0 degree Celsius, so obviously it will melt. First it will melt to water whose temperature will be initially 0 degree Celsius. Then this water will absorb the heat and raise its temperature to whatever value, whatever amount of heat it is getting absorbed. So when this change happens, the state change happens, ice to water, solid to liquid, the amount of heat absorbed won't be seen as a rise in temperature. See, the temperature remains here. If you keep a thermometer, you can see that when this whole ice is getting melted into water, the thermometer value remains constant. It does not vary from 0. So when this state change happens, it happens at a constant temperature. Normally, whenever a body absorbs a heat, the moment it absorbs the heat, it can be seen as a rise in its temperature. The thermometer will show a rise in value. But when the same body absorbs heat for its state change from solid to liquid or from liquid to gas, the amount of heat absorbed won't be seen as a rise in temperature. Rather, that amount of heat is completely used by that body to change its state, and that since the heat is not seen outside, you call it as latent heat, which is not seen outside as a rise in temperature. So that is latent heat. So when ice melts, you call it as latent heat of fusion. When water gets vaporized into the water vapor or gaseous state, you call it as latent heat of vaporization. So latent heat of fusion and latent heat of vaporization. Hope you understood what is heat capacity, what is specific heat capacity, what is latent heat. Now for ice, latent heat of vaporization, that is L for ice is, so this is the second equation, Q is equal to m into L, and for ice, L value is 336 joules per gram. Means for 1 gram of ice, at 0 degrees Celsius, 1 gram of at 0 degrees Celsius ice at 0 degrees Celsius requires 336 joules of heat to get converted into 1 gram of water at 0 degrees Celsius. So that's the mean. Hope you understood the two equations. Now let's get back to the question. Before that, there is a principle called the principle of calorimetry, which tells you how the heat is being transferred. If you close down all other ways through which heat can absorb or heat can go or heat can be transferred to the surrounding, then you can say if two bodies are intermixed, one body with a higher temperature which is having more heat and another body at a lower temperature, when they are intermixed, obviously heat will flow from a body at a higher temperature to a lower body at a lower temperature. So if you close down all the ways in which heat can be evolved into the atmosphere, then you can say heat given out by hot body is equal to heat absorbed by cold body. So heat absorbed equal to heat evolved. So heat absorbed is equal to heat evolved. So this is the principle of calorimetry. So if someone loses the heat, that same amount of heat will be absorbed by the other members of that particular system. Now in this case, let us come back to the numerical. In this case, in this system, I can say that there are three people. One is the vessel, who is at 30 degrees Celsius, who reaches to 5 degrees Celsius, and there is water, who is also at 30 degrees Celsius, who also reaches to 5 degrees Celsius, and then there is ice, who is at 0 degrees Celsius, and he also reaches to 5 degrees Celsius. So three members are there. Now, who is losing the heat? The one who is at a higher temperature comes to lower temperature, so he will be losing the heat. So water and vessel is losing heat. Who will take up that heat? Ice at 0 degrees Celsius is reaching 5 degrees Celsius. His temperature is increasing, so he is taking up that heat. So ice is absorbing that heat. Now, we don't know how. The question is how much calculate the amount of ice is needed. So let us see what actually happens here. Let us find out the heat evolved by water. To find out the heat evolved by water, see, this happens at the same state. Water at 30 degrees Celsius becomes water at 5 degrees Celsius. Same state, liquid state. So when the heat transfer happens at the same state, the equation which you should use is Q is equal to mc delta T. Same state. The vessel also same way. Q is equal to mc delta T. Now for ice, see, initially ice is at 0 degrees Celsius. And what transformation will take up? The ice at 0 degrees Celsius will get converted into water at 0 degrees Celsius initially. Then that water will go to 5 degrees Celsius water. So ice at 0 degrees Celsius to water at 0 degrees Celsius. Which equation we should use? It is a change of state. So you should use Q is equal to M into L. Now once the the ice gets converted into water at 0 degrees Celsius, and then that water absorbs the heat to reach 5 degrees Celsius. Which equation you will use? You will use Q equals mc delta T. Is that logic clear? So let us write down the numerical. Here water, so mc delta T. So let this for water. So water loses its heat. How much is the mass of water? It is 150. 150 multiplied by how much is the specific heat capacity of water? We already told it is 4.2 joules per gram per degree Celsius. So 150 gram is given, so you should take 4.2. If kilogram was given, you should take it in kilograms, so 4200 multiplied by how much is the change in temperature happening. 30 degrees Celsius water is getting into 5, so change in temperature is 30 minus 5, so 25. Now who is the other person also losing the heat? That is this vessel. So vessel, what is mass? His mass is 50. Again the same equation, mc delta T, mass is 50. His specific heat capacity is 0.4 and his rise in temperature is again from 30 to 5. So how much temperature difference happens? So 25. So these two people are losing heat. Who is absorbing that heat? Ice. Ice absorb to change its state from 0 degrees Celsius to 0 degrees Celsius water. So which equation? 0 degrees Celsius to 0 degrees Celsius water. Ice to water. So you have to use ml equation, m into L. How much is mass of? Mass is not known. Latent heat is 336 joules per gram. Now 0 degrees Celsius water changes to or reaches 5 degrees Celsius. So which equation you have to use? mc delta T. So again, how much ice has got melted into water we also don't know. So again you have to write m there. M into C is 4.2 and delta T is from 0 to 5, so it is 5. So this is how the equation has to be written. Someone is losing, the other person is gaining. The losing one, whose temperature falls, that person is losing. The whose temperature rises up, that person is gaining. So when that person is gaining, you have to see whether the state change is happening or not. If the state change is happening, you have to include that also. For that you have to use the ml equation, and if the heat absorption takes place in the same state, you have to use the mc delta T equation. Now when you calculate this, m is common, so you can take m common outside, 336 plus 4.2 times 5 on one side, and when you multiply this 150 into 4.2 into 25, so it will be almost heat required. So you can find this m equals 16250 divided by 35 350Z. So you will get it as 45.52 grams. Check it out. Hope you understood the logic. I explained what heat capacity is, what specific heat capacity is, where do we use the Q is equal to mc delta T equation, where do we use the Q is equal to ml delta equation. If you know all these things, you can attempt these sort of numericals. Thank you.